Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Well, hello, and welcome to, or welcome back to, the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show. We're almost a year and a half of being here with you every single week. We designed this show to be a resource for those who work in and around PLM. The Digital Enterprise Society, it is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor every single week to co-host this show with Craig Brown. Now, Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm great, Tom. It's good to hear your voice. Glad to be doing another podcast.
You know, every single week I look forward to our little chats with some really smart people, and I'm excited because today we have with us Jim Van Os. And Jim, I actually met him at PLM World many years ago. He said we shared a taxi on the way to the airport after the show. And so I am suddenly having memories of what a nice guy he is, too. So we are going to have a really good talk because every single week, Jim and I, we try to bring to this show interesting interviews and other ideas that are going to help the listeners enhance and grow their careers. So today we're going to talk to Jim. Now, he is both sort of half engineer, half information technology. He's spent his career doing both. And he tells me that to really be active with PLM, you really have to be both. You have to know the IT side and the engineering side, and he's got both of those. He is the Aerospace and Defense PLM strategist and architect at Moog, Inc. Hey, Jim, welcome to the show.
Thanks, Tom. Thanks, Craig.
So, Jim, can you give us a little bit of your background? Where did you start off in your career? What was that sort of half and half engineer IT world?
Well, I have a couple of degrees in mechanical engineering. From the University of Buffalo. I worked for a short time in the machine tool industry, making punch presses, robots, and press brakes. And then I went over to Moog Inc. about 36 years ago, almost exactly, and started, I was a design engineer designing spacecraft, propulsion controls. Some people call it rocket science. Did that for about half my career. Had the privilege of working on space shuttle and space station. I have hardware that's flown on both programs. Then I got interested in the web and IT. I ran engineering applications for about 4 years. And then I became CIO at Moog for about 13 years. After that stint as CIO, I went back to engineering, managed the propulsion product line for a while. And then I got asked to figure out how to put PLM in at Moog and how to get rid of drawings, which led me to my current journey.
And how you doing? Are the drawings gone?
The drawings are not gone.
They never are.
But we have a path. We have a path with PMI and model-based definition to get ourselves there.
That's fascinating. I think, well, let's start with the first question. You're the PLM strategist, and you clearly have the broad background you need to do that job. How was it that Moog became aware that they needed it?
So we've had Team Center for probably 25 years. I was one of the guys that bought it when it was called iMan. It since became Team Center. And we used it for product data management. So we used it to store drawings. And that's all we used it for. But then we sort of realized when I was tasked with my latest assignment, I came up with a strategy, figuring out I better do a strategy because I'd like to keep this job for a while. And without a strategy, this is just going to be installing a new version of the software. So the strategy ultimately was to transform engineering, and which is really important advice for anybody in this realm. Right. If you're just hanging around putting new software in, you're not really differentiating yourself. But if you can come up with a strategy that is compelling from a business perspective that entails doing product lifecycle management, that's what really works. So we came up with the strategy. I came up with a strategy to transform engineering by getting to model-based definition, eliminating the data chase, and managing intellectual property better than we have done in the past.
So by transforming engineering, then it's much more than just tool cost. It's got to be the engineering process, maybe even time to market. Were those part of the metrics to improve the place?
Yeah. So it's really how you do work differently. So it's kind of hard to sit down and say, oh, well, if you do model-based definition, model-based enterprise, you'll get all these savings, because we really don't know what they're going to be. But we do know if we do that, it's a step in the right direction. It's hard to quantify, but we could begin to quantify eliminating the data chase. So where people spend, I don't know, 40% of their time looking for information.
All right.
If you reduce that on an engineering department, that's a pretty decent amount of return. So we thought that was a good idea.
Yeah. So you're right. It's more than licenses. It's the wasted hours searching. We did a similar study in my former career, and it was embarrassing what the data told us. And it turned out, strategic elements about, well, one of the things to go after is legacy systems, right? So not custom or not commercial software, but custom software that hard to maintain. Maybe the original authors have retired and all that. And I was surprised at the difficulty of moving off of legacy systems. I learned it was partly the knowledge embedded in those systems. That in one case, it was a release system, right? And so there's a lot of knowledge in there. Well, you would think Team Center could handle that. And we were surprised over and over the challenges we had. It had a lot to do with the user experience and how many clicks you had to click and all that stuff. So what were your, if you're willing to talk about it, what were the resistances to change? Or did everybody realize we really did need to change?
So you recall an interesting and parallel story that we have. So I was the smart guy in the early days that said, oh, we don't want to pay graphics for the licenses for iMan, so we'll just make copies of our drawing and serve them on the web, which we did. And so we were serving, I think, 5.5 million drawings a year using this homegrown web system. We've recently transitioned that, moved all that back into Team Center in Active Workspace, so that's being delivered that way. But the real interesting part is the value we're trying to bring with the strategy. So part of the strategy in eliminating the data chase, letting people find stuff faster, we're going to get there with classification. But the other thing we're going to use is something called the Bill of Information. So the Bill of Information, as you might guess, an engineer that's tasked with cranking out a drawing, or maybe in the digital twin days, a model, and it works both ways. The end result is that drawing or model. But all the other artifacts that engineers work on, the trade studies, the analysis, the simulations, all the correspondence, all that other stuff gets stored everywhere and anywhere in any old way and not very carefully. So we created, using Team Center specifically, but I'm sure this will work with other PLMs, pseudo folders, which are essentially relationships. So all those other artifacts can be stored in the PLM and can have revision lives of their own if that's appropriate from a configuration management perspective, and related to the part or the process or the assembly or what have you in the PLM. Because PLMs, at the end of the day, are made to keep track of assemblies of things. That's all they do. And so if you think of a model-based definition, if you think of things as not the most atomic thing is the part, but the part becomes an assembly of other things, that's what PLMs are good for. So if you begin to break down those paradigms, you can create a pretty good value system. So the classification, and particularly the Bill of Information, has proven very valuable and very attractive for our company. And that's helped really to fuel the interest and the value and the perseverance with this program that we're on. Okay,
so explain to me, is the Bill of Information a child of the Bill of Design or the Bill of Materials, or is it its own object and you somehow relate them all?
It's a parallel world. So the factory runs on the Bill of Material, right? So the Bill of Material is the list of parts, if you will, that goes into making the widget or the product that you're ultimately going to sell to a customer. But the analysis, the maybe specification references, the sizing, the simulation, and so on are needed in order to size and have confidence that the part will perform properly to the requirements, but they're not part of what the factory produces. However, if you have a problem or you have to go through a review, like a critical design review, you need that information to basically prove to your customer that you did things the right way and you have the proper backup for all the decisions you made.
Okay, so like a bill of materials, you have somebody who's a specialist at constructing that and keeping it up to date, and some of it's automatic. If you got other tools linked to Teamcenter, these other bill of information, is it the same way? There's an analyst or an expert that keeps the bill of information current. I could imagine from a preliminary design review to a critical design review, there's different versions of these pieces of information. Is that done automatically, or is that a job function that's in your company?
That's really done by the engineers. So
okay, so the engineer himself, the person responsible for the design,
right? They know if there's a change to a part that adds another hole or different radius or something like that needs to have an updated strength analysis or simulation. If the mass changes, the simulation may have to change. They know that. And you can, using the PLM or Teamcenter specifically, you can status that. So if the status of the part changes to the next revision, that can be the signal to the engineer who's responsible for, say, the supporting analysis, that they need to go check that to be sure that, this thing changed. Maybe my analysis needs to be updated. So you can check to see when things are out of date.
So that's a good example. So is it the engineer that says, I got too close to the safety margin, or is it the analyst that's always watching that says, hey, I think we should take another look at that? Your design change has put us back in, too close to the safety margin. Or is it a joint? I mean, maybe they both do it.
I believe that it's joint. I mean, we're just introducing the bill of information now. So if you fast forward to the digital twin and the model-based world, if you have proper models for all these things that are properly linked with singularity, as you might want to have in a PLM, then and those are parameters that are globally available for that particular part or product, they should be updated fairly automatically, or at least flagged that they need to be.
Yeah, and I think this is where computers, they're fast enough now and they're cheap enough. They could help, right? They could maybe take a notion of, well, here's your current safety margin consumption. And then as your design changes, did that improve or get worse, right? And then if it gets too worse, you can decide to redo analysis or redo physical test even. So computers could help with that. So you mentioned in your note to myself before we had the interview about the importance of taxonomies. And I'm imagining three bills, if you will: the bill of information, the bill of design, and the bill of manufacturing, which you wisely pointed out that's what manufacturing needs. Or the bill of material. So are these all the same taxonomy, or are they just different, and it's the engineer that traverses them?
I believe, so taxonomies apply to lots of things. So as taxonomies applies to bills of material, that's a simple taxonomy from an engineering perspective. You have an assembly with a bunch of parts, maybe a sub-assembly, which it has a bunch of parts, and so on and so forth. So recursively runs its way down the tree. I'm a big believer of singularity, so I'm of the school that says there should be one bill of material to rule them all. So we're using the Lord of the Rings, one ring to rule them all. And then you can look at it. You should be able to look at it with different views, right? So if you're a manufacturing person, you better burn down that entire bill of material, because if you leave something off, then it doesn't carry all the design intent that the engineer had put in. So a bill of material, a manufacturing bill of material should be a version of the engineering bill of material. Now, you may create it differently or structure it differently with a different taxonomy, but ultimately you should be able to consume all the leaves of that taxonomy, if you will.
Okay.
But taxonomies also apply to lots of other things too. So it applies to how you might classify something. It's basically how you organize stuff. And the only way to really organize stuff is to lay it all on the floor and figure out what piles of stuff should go together. And then you can
Well, when I try to teach taxonomy in my past life, I reminded people what was their first experience with a library, right? And how did you find something in a library? Well, at the end of the day, it's really a taxonomy, right? The way it's indexed and all the rest of it. So, okay, so how far in your industry, how far does PLM go? Is it just to the point of manufacture, or is it longer than that?
Our vision for that is that it should go all throughout the entire product lifecycle, all the way to retirement of the product. We make
Okay.
a lot of hardware. We make a lot of hardware that goes into space or on missiles. So the repair and overhaul part of that business is almost non-existent. But we also make a lot of hardware that goes on military and commercial aircraft, which does have a lot of repair and overhaul life. And having all that supporting documentation over the life of a program, if you have an actuation program on a flight control, that could be 30, 40 years or more. Everybody who worked on it is going to have retired by the time it needs to be repaired, most likely. So it's nice to have all that supporting documentation, which explains, well, why did they pick this particular finish, or why did they pick this particular seat? And that's typically lost to time in the traditional historical engineering sense. But with a properly implemented PLM, you can preserve all that and preserve that for the future. And then if you want to make a new design using that existing, all that good stuff, all that goes along for the ride, right? So if you file save as, all that other documentation you get for free. So that saves, that's a lot of reuse, and that saves a lot of time and has a lot of value.
So I think that's one of the things we large companies, I'll put us all in the same bucket for a moment, we're beginning to realize that we have groups in service and sustainment, they call it in your industry. And in fact, a lot of times those people did copies of records and then divorced themselves from engineering and manufacturing, because that, like a car company, well, that's where the mainstream is anyways, not in service. Well, now that you talk about upgrades in the field being commonplace, especially control systems, the digital side of control systems with embedded software and avionics, it's like, well, shucks, that stuff can be upgraded every 5 years, every 4 years, even faster, right? So the whole idea that you wouldn't keep your bill of materials or your PLM throughout the whole life cycle till you dispose of the thing, that's going to happen. So interesting. Now, Jim, one of your other hobbies, if I will, is working with actually, you mentioned two of our working groups at the Digital Enterprise Society. Give us your summary of each of those, and also your role that you're playing in each of those.
So I work with two groups in the Digital Enterprise Society. One is the Materials and Compliance, or Substances and Materials, I don't remember the exact name, where we participate as a reasonably active member, I think. Because again, with model-based definition, we think materials are objects that shouldn't be notes on drawing, things that you drop onto a part so that the PLM knows what it's made of. And then the analyst can use it downstream and so on and so forth. And then when you want to do substance compliance, that's important too. So we're beginning to open that realm up, and that fits into our larger PLM strategies. So participation in that group is important. The other group that I participate in, and I've been in this group for, 5 years or so, is the Aerospace Working Group. And these are other aerospace companies. Typically, most of them are our customers. A few of them are our competitors. But in the PLM realm, in the Aerospace Working Group, using the various Siemens pieces of software, whether it's NX or Teamcenter, those are the main two, but there are others. There's a lot of common threads, common problems, interesting solutions, good benchmarking you can do to find out, well, how many people do you have supporting your PLM per employee? Exactly. How do you justify those differences? And so that's been a pretty valuable group to work in. We've had the opportunity through that working group to help define lots of requirements for Siemens that ultimately up into the product. So by being active in these groups, you can actually shape the direction of the software that you're trying to help influence. And so I've run a couple of projects that gathers requirements and transmits them to Siemens, which they have then incorporated into the product. I did that with Siemens, or it was Unigraphics at the time in the 1990s, for a particular type of feature we were looking for called user-defined features. I wrote the requirements for that back then, and they included that in the product ultimately. So they like to use customer input for that, because then they will then put that in the product. So there's a lot of value in those working groups in order to not only expand your professional horizon and meet other people, but also influence the software that you might use to help your company.
Yeah, and this is one of the reasons we wanted them to continue with the Digital Enterprise Society. We wanted these working groups to form as necessary. You mentioned two of the most active ones. I can remember in the early days of the material science side of it, again, our motivation was getting rid of a bunch of legacy systems where we were tracking all this stuff. And surely we could, either through partnerships or through benchmarking, move the needle in the right direction. And I think corporate Siemens, the other divisions of Siemens that use their tools, also had a hand in helping push it there. They're not necessarily aerospace, but they had the same desires: turbines and power generation and windmills and trains and so on. So it's interesting. I'm glad you summarized it so well. I would remind all of our listeners they should join working groups and make the time. Even when your competitors there, you can still find common ground on problems to solve, right? And avoid the topics where you're a competitor, right? Like,
well, yeah, and you can find out what your competitor is working on and decide, well, is that something I should work on, or gee, I already solved that problem, so maybe I won't talk about that. But it's really interesting to talk to other companies what things, issues they struggle with, and to uncover issues that everybody has that may not be sort of widely talked about. So one of the things was, how do we do an upgrade? And everybody, because Siemens, bless their hearts, are very good at telling you what's in the current product, and we love that. That's great. But generally, all these bigger companies are quite far behind. Are quite far behind in their revisions, and really struggle as we do to get to the next revision. So we get teased with what's in the latest revision, and we're sort of 3 or 4 revisions behind that, and it will take us 2 years to get there. And by the time we get there, they'll be 2 years ahead of us, and so on. So you're always catching up.
And I'm thinking of the business I came out of, and of course we were the ones pushing Siemens for the next release, and generally only one release behind in the car business, and it's true of most car companies. And we would just release every 18 months. I mean, it was just the normal practice, or every 2 years. Whereas a lot of aerospace companies, especially defense contractors, you're kind of stuck with what you start with, meaning contractually you're kind of stuck with it, right? It's hard to upgrade in the middle. It's hard for people to justify the cost.
Yeah, so that's an interesting conversation. So we are probably we've been as far as 4 revisions behind. I think right now we're 2, and we're hopefully going to catch up next calendar year. So this is calendar year 2020. So 2021 will catch up, at least for a while, and then we'll fall behind again. But going through, we use NX for manufacturing, so you have to do a lot of checking and testing to make sure that the new revisions work right. Way back when, this is an older version of NX manufacturing, where I believe the outward normals got reversed of the solid model, which means so what? Well, the so what is when you try to introduce a mill into a surface, you come at it to the wrong side of the part and you crash the machine. So you have $1 million machine tool you don't want to crash. So you have to really test a lot of this stuff. And for flight programs, qualification matters. It's important. So if you're changing anything anything substantial with your with any of your manufacturing processes, you may have to requalify some of that. And so that also is a big deal. And then also, a company like ours, we have dozens and dozens of programs that are running as fast as they can through the factory to get out to customers. And to pause and change the software doesn't really have a lot of immediate value. So it's hard to get the business excited about that sort of thing until you get so far behind where and all of a sudden you can't get new capability that you need.
Well, and ultimately that was the cultural awakening in the commercial or consumer products area. Was getting further behind was a bigger problem than taking that incremental hit in the middle of your release of your current program, right? And so eventually, I mean, we used to have leaders, chiefs, that would say, no, not now. I'm going to launch in 6 weeks. And we'd say, yeah, but we told you the schedule, and now time is here. So your launch will go on in parallel with the upgrade of the tools. And it was just expected, right? So my point is the culture was taught, this is what we have to go through to to stay competitive. It's just what it is. Right?
That might be different in the automotive company. In the aerospace world where I come from, never is a good time to upgrade.
Well, then you're satisfied with where you're at, and don't ever upgrade.
Well, that happens. That happens. But then you get when you get too far behind, you get all kinds of other issues creep in. Like you can't get an operating system that runs that software on a new, that old operating system.
Correct.
I need a new computer. I can't run that old stuff.
Yeah, so 10-year life cycles in workstations and laptops and PCs, that doesn't exist anymore. Maybe we'll go back to it.
Keep up, to a point, because otherwise, then now also with the advent of cybersecurity now, so everybody's much more sensitive to cybersecurity. Again, those older versions aren't as secure as the newer versions, and then the IT department will sort of force that hand, if you will.
You reminded me, this is a bit of a tangent, but let's go there for a second. You reminded me of a comment I heard. If he's listening, he'll remember he said it. But we won't name him in public. But it was a tool developer, and I asked him, I said, what do you worry about? I was in the leadership position. I was buying these incremental tools, right? And I was flabbergasted by his answer. He said, I don't know the software that's in my tool. And I'm like, what do you mean? And he said, well, there's so many libraries shared now, and we're moving so fast in order to put new capability into the tools that every now and then I'm really unsure of the legacy of some of that software. And when you ask the cyber question, what's the threat? Well, the threat could be huge, right? A Trojan horse and all the rest of it. So it's interesting to me that maybe we're going, and my conclusion was maybe we're going a bit too fast. We should still do the due diligence. And it's like understanding material properties. You really should understand what it's made out of, right? So that you don't create a threat. So some of the newer software is actually a bigger cyber threat only because we got the, metal to the, or pedal to the metal. We're fully accelerating and maybe going a little too fast, right? Without prudence on checking things. So.
And you get very dependent on all these different automations, and all of a sudden,
oh yeah, you forget.
All of a sudden, it's a big problem.
Yeah. Well, Jim, it's been very nice chatting with you, and I wish you well in your strategy job. I can tell from the pictures of each other, we're dealing with COVID, meaning we're working from home. We've been asking guests this question. I assume most of your folks like yourself are still working from your remote offices.
We are. So our team is pretty far flung. So it really doesn't matter if I'm in the office or at home, because I'm going to be on the phone or doing a web conference with them. And so there's a lot of value in that respect in being home, because you don't have to commute, you save time getting ready and so on. But you don't get the collaboration that you do face to face, which is something that we do miss.
Well, and I would assume you still do physical inspections. And so getting to the plant or wherever you're building a mock-up, you still need to do something, or are you doing that virtually as well?
Our staff that has to deal with the product is coming into work. So they are coming to the factory, and we've put in all the recommended steps plus a few more to keep everybody safe. And so far, everybody's been safe, and we've been able to function and operate pretty well.
Well, excellent. It's grand talking to you. Back to you.
So, Jim, before we let you go, you made an interesting comment when before I introduced you that you'd been there for 36 years. And a lot of people don't stay in one company for quite that long and have that breadth of different jobs within a company. What advice do you have, from your perspective, for people who are listening to the show about how to advance their career, whether they stay with a company or whether they change companies? You've seen a lot, and being CIO, you managed a big team. What career advice do you have?
I would say, pay attention to the company culture. That's what kept me at Moog so long. So if you find a place with good culture, good place to work, those companies are valuable. I won't say they're few and far between because I don't have a big sampling rate. My sample is 2. So if you find a good culture that's good, if you have a company that's big enough, Moog is big enough. Moog is something around 12,000 employees or so. So there's enough job variety available internally, so you can sort of bounce around, follow your interests inside the company. You tend to do better at things you're interested in than things you're not interested in. So I would tell people, follow your passion, follow what you're interested in. And if you may need to do a strategy to make a job out of it, I was able to do that. I was fortunate enough to do that. And that's what I would say.
And what's it like inside a big company to head up an initiative like you're doing with this PLM initiative?
Well, this has been an interesting journey because it started with a staff of one, and now we have 30 plus people working on it. So it's taken off. It's pretty good, and you really are able to follow your passion and follow the interest of getting something in that makes, at least from my perspective, engineering a better world. Right? I want to make engineering better for our engineers, and I think by implementing PLM in the way we've created it and configured it and customized it, we can do that.
Well, again, Jim, thank you so much for sharing with us here on the Digital Enterprise Society podcast. Craig and I are here every single week. So if you're listening, if this was your first time to tune in, come back every single Wednesday. We have a brand new show where we're going to bring you thoughts, ideas, and information in and around product lifecycle management. Hey, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.